Have you ever looked up at the night sky and wondered what's really out there? Beyond the stars and planets, there are enormous clouds of gas and dust, nebulas, where the universe creates its most spectacular wonders. Some are stellar nurseries, giving birth to new stars, while others are remnants of stars that have exploded or died. Today we're diving into the fascinating world of nebulae, exploring their beauty, mystery, and the incredible stories they tell about our cosmos. Fact 1. What is a nebula? Have you ever looked up at the night sky and noticed a fuzzy patch of light that wasn't a star? That, my friend, is the beginning of a nebula, but calling it fuzzy barely does it justice. Imagine a cloud, not in our sky, but in space, a glowing, shifting, mysterious cloud made of gas and dust, often stretching across light years. That's a nebula. Nebulas are like the universe's paintbrushes. They come in every shape, colour, and size you can imagine. Some are the birthplace of stars bubbling with energy and life. Others are the remnants of stars that have died spectacularly, scattering their guts across the cosmos. Either way, each nebula tells a story of birth, destruction, or transformation. What's fascinating is that nebulas are not just empty space. Even though they might seem like ghostly clouds, they're filled with the raw ingredients of the universe: hydrogen, helium, dust, and even some more complex molecules. These ingredients are the same ones that make up stars, planets, and eventually life. In a way, when we look at a nebula, we're looking at the universe in the middle of a cooking experiment that lasts millions of years, and they're huge. Some nebulas are so large that if you tried to measure them in miles, your numbers would get laughably unwieldy. We're talking dozens to hundreds of light years across. That means the light we see from the edges left that nebula decades, centuries, or even millennia ago. Essentially, looking at a nebula is like peeking back in time, catching a cosmic scene in mid-action. Nebulas can be found in every galaxy, and they're often the most visually stunning objects in the sky. Think of those bright, colourful pictures you've seen from the Hubble telescope. Those aren't just for decoration, they're real clouds of gas and dust shaping the universe around us. So next time someone asks, what is a nebula? You can tell them it's not just a cloud. It's a cosmic nursery, a star's graveyard, a chemical lab, and a painter's palette all rolled into one, and each one has a story waiting for us to discover. Fact 2. The meaning of nebula. Latin, cloud. You know how sometimes the origins of a word reveal a lot about its story? Take nebula, for example. The word comes straight from Latin and it simply means cloud. Yep, ancient astronomers looked at the sky and said, that fuzzy thing looks like a cloud, and that name stuck. There's a kind of poetic charm to that, isn't there? A human trying to describe something billions of miles away with just a word they knew. Back then, they didn't have telescopes powerful enough to see all the details we can now. All they had were their eyes, and a lot of imagination. They gazed at the night sky and saw patches of light that didn't twinkle like stars. These glowing blobs seemed ethereal, mysterious, even a little magical, and so they called them nebulas, clouds in the sky. What's funny is that this name is both accurate and misleading at the same time. Accurate because nebulas do look like clouds, soft, diffuse, and often flowing across the sky. Misleading because, unlike Earth clouds, they are not made of water vapour. Instead, they're made of gas and dust, hydrogen, helium, and heavier elements. And their scale is unimaginable. An average nebula could easily stretch tens of light years across. Compare that to even the largest clouds we know on Earth, and you start to see the cosmic mind-blowing factor. Even today, the Latin root reminds us that humans have always tried to make sense of the unknown by comparing it to what we already know. And in a way, that's what science is. A bridge between the familiar and the mysterious. Nebulas remain the same mysterious clouds the ancients saw, but now, through modern technology, we can study them, photograph them, and even understand the processes that give them their shapes and colours. So next time you hear the word nebula, remember, it's a cloud, yes, but a cloud that's billions of miles away, full of raw materials for stars and planets, and infinitely more fascinating than any cloud you'll ever see on Earth. Fact 3. Types of nebulae. Overview. When most people think of a nebula, they imagine one glowing cloud floating serenely in space. But if you look closer, you'll discover that nebulas come in many flavors, each with its own personality. Scientists usually categorize them into a few main types, though there's plenty of overlap. First, we have emission nebulas. These are glowing clouds, lit up by nearby stars. The stars energize the gas, making it shine in brilliant reds, pinks, or sometimes blues. Think of the Orion Nebula. It's one of the most famous examples and a stellar nursery where new stars are born. Then there are reflection nebulas. These are more like cosmic mirrors. They don't glow on their own. Instead, they reflect the light of nearby stars, often giving off a soft bluish glow. It's like someone shining a flashlight onto fog. The light bounces, creating something beautiful and ethereal. Next up are dark nebulas, which are almost the opposite. They're clouds so dense that they block the light behind them, creating dark silhouettes in space. They might seem empty, but inside they're full of gas and dust, often incubating future stars in secret. The Horsehead Nebula is a famous example, its shape carved out of cosmic shadows. Finally, there are planetary nebulas, which are misleadingly named because they have nothing to do with planets. They form when stars like our Sun die and shed their outer layers, creating a glowing shell of gas. These nebulas are relatively short-lived in cosmic terms, but they're stunning and colourful. So you see, nebulas are not one-size-fits-all. Some are birthplaces, some are death masks, and some are just there, quietly reflecting light or blocking it. And these types often overlap, making each nebula unique in shape, colour, and story. Fact 4. How nebulas are discovered. Discovering a nebula isn't like stumbling upon a hidden treasure chest in your backyard. It's more like patiently listening to the whispers of the universe. Early astronomers noticed fuzzy patches in the night sky with their naked eyes. But it wasn't until the invention of the telescope that nebulas began to reveal their secrets. Take Galileo, for instance. When he peered through his telescope in the 17th century, he saw stars in places that looked like clouds. He didn't know it then, but he was glimpsing what we now call nebulas. Over time, telescopes became more sophisticated, allowing astronomers to see finer details, different colours, and the motion of gases. Fast forward to today, and we have space telescopes like Hubble. These instruments can capture images of nebulas in stunning detail, across multiple wavelengths, visible light, infrared, even X-rays. That's how we can see the pillars of creation in the Eagle Nebula, or the swirling colours of the Carina Nebula. Each discovery builds on the previous one, peeling back layers of mystery. Sometimes, nebulas are discovered indirectly. For example, astronomers might notice unusual light patterns or spectral signatures that indicate a cloud of gas is present. Other times, a supernova explosion might reveal a hidden nebula behind it, suddenly lighting up a previously dark region of space. It's a reminder that in astronomy, discovery is often a mix of patience, technology, and a little luck. Fact 5. The historical fascination with nebulous humans have always been fascinated by mysterious clouds in the sky. Long before telescopes, people noticed strange, diffuse lights scattered across the night. Ancient civilizations didn't call them nebulas. They wove them into myths and legends, sometimes seeing them as portals, spirits, or omens. During the Renaissance, astronomers like Messier began cataloguing these fuzzy stars to distinguish them from comets. The famous Messier catalogue still guides astronomers today. Each entry tells a story of curiosity and wonder, a person staring into the sky and thinking, "What is that?" Later, as technology advanced, nebulas shifted from being objects of myth to objects of science. The discovery that some nebulas were stellar nurseries and others were the remnants of dead stars added layers of drama and beauty. The sky became a stage, and nebulas were the actors, performing stories of life and death on a cosmic scale. Even today, nebulas inspire art, literature, and imagination. Their shapes, colours, and sheer scale make them symbols of mystery and possibility. From ancient stargazers to modern astrophotographers, nebulas have always held our attention, and they probably always will. Fact 6. Nebulas in ancient astronomy. Imagine standing under a clear night sky thousands of years ago. There were no telescopes, no satellites, just the stars and a vast mysterious darkness. Ancient civilizations noticed strange, fuzzy patches among the stars, some brighter, some darker, some almost ghostly. These were the first glimpses of what we now call nebulas. The ancient Babylonians, Greeks and Chinese all observed these hazy objects. They didn't understand their true nature, of course. Without the science we have today, they often wove them into myths. Some saw these clouds as celestial smoke, while others thought of them as gateways to other worlds or resting places for spirits. There was a sense of awe, a recognition that these patches of light weren't ordinary stars. The Greek philosopher Democritus, who imagined the universe as tiny indivisible atoms, may have looked at these clouds and wondered if they were made of some fundamental cosmic stuff. Meanwhile, in China, meticulous records were kept of unusual star patterns, some of which we now identify as supernova remnants or bright nebulae. Even if they didn't understand the physics, they were observing the same phenomena we study today. What's fascinating is how human imagination met observation. Nebulas weren't just points of curiosity, they were markers of the unknown, symbols of wonder, and invitations to question the cosmos. And though the ancient skywatchers couldn't name them stellar nurseries or measure their gas composition, they laid the foundation for centuries of curiosity that would eventually lead to modern astronomy. Fact 7. The role of telescopes in studying nebulas. Fast forward a few thousand years, and suddenly humans had tools that expanded our vision beyond the limitations of our eyes. The telescope changed everything. When Galileo first pointed his primitive telescope toward the night sky, he noticed details that had never been seen before. Stars appeared, where previously there had been fuzzy clouds. Telescopes allowed astronomers to see nebulas not as vague smudges, but as complex structured objects. For example, the Orion Nebula, once a mysterious patch of light, revealed filaments, glowing gas, and dark lanes of dust. Observing these details led to questions. How do these structures form? What are they made of? Over time, technology improved. The 19th and 20th centuries brought larger ground-based telescopes and eventually space telescopes like Hubble. These instruments let us see nebulae in multiple wavelengths: visible light, infrared, ultraviolet, even X-rays. Infrared can pierce through dust to reveal stars forming inside, while X-rays show the aftermath of massive stellar explosions. Telescopes transformed nebulas from mystical patches of light into laboratories for studying star formation, chemical composition, and cosmic evolution. They turned wonder into measurable science while still keeping the awe intact. Every telescope, from the earliest lenses to modern space observatories, has allowed us to read more of the stories written in these cosmic clouds. Fact 8. Famous astronomers who studied nebulas. When you think about nebulas, it's impossible not to think about the astronomers who made them visible to the human mind. Charles Messier, for instance, catalogued over 100 nebulas in the 18th century to avoid confusing them with comets. Messier's catalogue is still used today and is a testament to careful observation and relentless curiosity. William Herschel, who discovered Uranus, also studied nebulas in depth. He noted the variety in shapes, sizes, and brightness, and even speculated about their composition. Later, Edwin Hubble revolutionized our understanding by showing that some nebulas were not clouds within our galaxy, but entire galaxies themselves, far beyond the Milky Way. These astronomers weren't just collecting data, they were storytellers, translating mysterious lights in the sky into knowledge. Their work laid the foundation for modern astrophysics, allowing us to understand not just what nebulas are, but how they fit into the larger story of the universe. Fact 9. How nebulas influenced science fiction. Nebulas haven't just captured astronomers' imaginations, they've inspired writers, artists, and dreamers for centuries. From early 20th century pulp magazines to modern films like Guardians of the Galaxy, nebulas often appear as mysterious, colourful clouds, gateways to other dimensions, or scenes of cosmic battles. Science fiction writers love nebulas because they evoke the unknown. They're beautiful yet dangerous, vast yet intimate, a perfect metaphor for exploration. Some stories imagine ships navigating glowing gas clouds, while others depict civilizations hiding within these cosmic clouds. The real science of nebulas, star formation, supernovae, chemical complexity, adds authenticity and wonder, blending fact with fiction seamlessly. Even today, nebulas continue to inspire art and storytelling, reminding us that the cosmos is not just a place to study, it's a place to dream. Fact 10. Why nebulas are called stellar nurseries. Have you ever seen a cloud where babies are born? Sounds strange, right? But that's the poetic image astronomers use when talking about nebulas. Many nebulas are dense with gas and dust, providing the perfect conditions for stars to form. Inside these clouds, gravity pulls material together, creating protostars that will eventually ignite nuclear fusion and shine as full-fledged stars. The Orion Nebula is a prime example. Looking at it through a telescope, you can see pockets of gas where stars are forming right now. These stellar nurseries are incredibly active, chaotic and beautiful, full of energy and motion. And the stars that emerge often go on to form entire planetary systems, meaning that nebulas don't just create stars, they lay the foundation for potential worlds. Calling nebulas stellar nurseries captures the wonder of creation on a cosmic scale. They are literal factories of stars, quietly shaping the future of galaxies over millions of years, and giving us a glimpse of the life cycle of the universe itself. Fact 11. Nebulas from supernova explosions. Imagine a star going out with a bang, a supernova. The explosion is so powerful that for a brief moment it can outshine an entire galaxy. But what happens after the fireworks fade? That's where a nebula often appears. A supernova leaves behind a cloud of gas and dust, a chaotic, colourful remnant that slowly drifts through space. The Crab Nebula is the most famous example. About 1,000 years ago, a massive star exploded, and the remnants formed a glowing nebula we can still see today. It's not just a pretty picture. The gases are rich in elements like carbon, oxygen, and iron, which are the building blocks of future stars and planets. In a way, the death of a star sows the seeds for new life in the cosmos. Supernova remnants are chaotic and turbulent. Shockwaves ripple through the gas, compressing some areas and scattering others. The explosion can even trigger the formation of new stars in nearby clouds. It's like a cosmic cycle. A star dies in a spectacular way, its remains spread across the galaxy, and new stars eventually emerge from that material. So when you see pictures of colourful, intricate nebulae, remember, they're not just random clouds. Many of them are the aftermath of violent stellar deaths, marking both the end and the beginning of cosmic stories. Fact 12. Nebulas formed by dying stars. Not every nebula comes from a supernova. Stars like our Sun also create nebulas when they die, though in a less explosive way. As these medium-sized stars reach the end of their lives, they swell into red giants and gradually shed their outer layers. These expelled gases form a glowing shell around the dying star, creating a planetary nebula. Take the Ring Nebula, for example. From Earth, it looks like a glowing ring in the sky, but it's actually a three-dimensional cloud of gas expanding outward. Over thousands of years, the star at the center will fade, leaving behind a dense white dwarf, while the nebula slowly disperses into space. These types of nebulas are important because they enrich the galaxy with heavier elements, carbon, nitrogen, oxygen, which later contribute to the formation of planets and maybe even life. So in a sense, stars like our Sun die not just quietly, but with a gift for the universe, the material to create the next generation of stars and worlds. Dying star nebulas are often symmetrical and beautiful, reminding us that even death can be creative in the universe. They are a gentle counterpoint to the violent supernova remnants, showing a quieter but equally fascinating way that stars influence their surroundings. Fact 13. Nebulas born from stellar winds. Some nebulas aren't formed by explosions or dying stars, but by constant stellar winds, streams of particles blown off from massive hot stars. These winds can push surrounding gas and dust outward, sculpting it into spectacular shapes over thousands of years. Think of the Bubble Nebula. It looks like a giant soap bubble in space, created by the intense wind from a central star pushing against surrounding material. Other regions might form arcs, filaments, or cavities, depending on the density of the gas and the strength of the wind. Stellar winds can also trigger star formation. As the gas is compressed by the wind, pockets of material may collapse under gravity, forming new stars. So, even without an explosive event, a star can dramatically reshape its environment, creating both beauty and opportunity for new cosmic life. It's a reminder that stars are dynamic actors in their neighborhoods. They don't just shine, they shape, sculpt, and seed the universe around them in ways that take millions of years to unfold. Fact 14. Nebulas from interstellar gas accumulation. Not all nebulas start with a dramatic event. Some form more quietly from the slow accumulation of interstellar gas. Over millions of years, clouds of hydrogen and helium gather in certain regions of space, slowly thickening until gravity takes over. These diffuse clouds can stretch for dozens of light years, forming the raw material for star formation. These gas clouds are often the first step in creating massive stellar nurseries. Unlike a supernova remnant or a planetary nebula, these regions can remain relatively stable for long periods, quietly waiting for the right conditions to collapse into stars. They're like cosmic waiting rooms, holding the potential for incredible activity without making much noise. Even though they may seem calm, these accumulations are fundamental to the life cycle of the galaxy. They're the reservoirs of material that fuel new stars, nebulae, and eventually planets. Without these quiet clouds, the dramatic displays we see in other nebulas wouldn't exist. Fact 15. The role of gravity in nebula formation. Gravity is the unsung hero behind nearly every nebula. Whether a cloud is the aftermath of a supernova, the result of stellar winds, or a quiet accumulation of interstellar gas, gravity plays a key role in shaping and compressing the material. Inside a nebula, gravity pulls gas and dust together, forming clumps that can eventually become stars. The interplay between gravity and other forces, like pressure from radiation or turbulence in the gas, determines the structure and evolution of the nebula. Some areas collapse quickly, forming protostars, while others remain diffuse for millions of years. Even in chaotic supernova remnants, gravity helps shape filaments and knots of material. It's the invisible sculptor behind the scenes, orchestrating the dance of matter on a cosmic scale. Without gravity, nebulas wouldn't condense into stars, and galaxies wouldn't have the stellar populations we see today. In short, gravity turns clouds of gas and dust into something meaningful, turning potential into creation. Every nebula is, in a way, a playground for gravity, showing us how the universe turns chaos into stars, planets, and maybe even life. Fact 16. Nebulas as remnants of planetary systems. We often think of nebulas as star nurseries, but some are actually cosmic leftovers, remnants of planetary systems that once existed. Imagine a solar system much like ours, orbiting a star that eventually dies. As the star ages, it sheds gas and dust into space. Over time, this material spreads out, creating a faint, diffuse nebula. These remnants aren't just debris. They're a glimpse into the life cycle of planets and stars. In some cases, rocky or icy fragments from former planets may survive inside the cloud, slowly drifting through the nebula. Studying these clouds allows astronomers to understand how planetary systems evolve and even hints at what might happen to our own solar system billions of years from now. It's fascinating to think that some nebulas are like ancient snapshots, preserving material that once orbited a star. They tell stories not of beginnings like many nebulae, but of endings, quiet, beautiful, and full of potential for future cosmic creations. Fact 17. Nebulas formed by star collisions. Sometimes, space isn't gentle. Stars can collide. While it sounds catastrophic, these cosmic crashes create something spectacular, a nebula. When two stars meet, their outer layers can be violently stripped away, forming a cloud of gas and dust that glows in intricate shapes and colours. Star collision nebulas are relatively rare, but they offer incredible insight into the physics of stars. The impact can trigger shockwaves that compress surrounding gas, potentially starting new rounds of star formation. It's a violent form of creativity, a dramatic ending that leads to new beginnings. In some ways, these nebulas are cosmic fireworks, showcasing both the raw power and unexpected artistry of the universe. They're chaotic, beautiful, and a vivid reminder that even destruction has a place in the cycle of creation. Fact 18. Dark nebulas and their origins. Not all nebulas glow brilliantly. Dark nebulas are the mysterious, shadowy figures of the cosmic stage. They're dense clouds of gas and dust that block the light from stars behind them, appearing as black voids in the starry sky. Think of them as cosmic silhouettes, hiding secrets within. These clouds are often the birthplaces of stars. The dust and gas inside dark nebulas can collapse under gravity, forming protostars in regions completely hidden from view in visible light. Infrared observations are key to peeking inside these dark clouds, revealing activity invisible to the naked eye. Famous examples include the Horsehead Nebula in Orion. Its distinct shape has captivated astronomers and stargazers alike, a perfect blend of mystery and potential. Dark nebulas are reminders that the universe is not always bright and colourful. Sometimes it's the shadows that hold the most life. Fact 19. Reflection. Nebula. Formation. Not every nebula shines on its own. Reflection nebulas are more like cosmic mirrors. They form when starlight bounces off nearby dust clouds, creating a soft, ethereal glow. Unlike emission nebulae, they don't generate light from ionized gas. They simply reflect the brilliance of neighboring stars. These nebulae are usually blue because blue light scatters more easily than red light, just like our sky here on Earth. They often appear near young stars or star clusters, highlighting the surrounding environment in a gentle, dreamy way. The Pleiades star cluster in Taurus is surrounded by reflection nebulas, giving it that characteristic soft blue haze. These clouds show that sometimes beauty in space comes not from energy or explosions, but from the quiet dance of light and dust. Fact 20. Emission nebula formation. Now, emission nebulae are the dramatic performers of the nebula world. Unlike reflection nebulae, they glow because their gas is ionized, energized by nearby hot stars. This ionization excites the gas, which then emits light in brilliant colors, often red, pink, or green. The Orion Nebula is a perfect example. Its glowing clouds are energized by massive stars at its center, creating a vibrant, almost painterly effect in space. Emission nebulae are usually sites of active star formation. They're literally lighting up the universe, showing us where new stars are being born. Watching an emission nebula is like seeing a cosmic fireworks show that never ends. These clouds demonstrate that space isn't static. It's alive, dynamic, and full of energy, with stars shaping the gas and dust around them in real time. Fact 21. Hydrogen as the most common element. When we talk about nebulas, the first element that comes to mind is hydrogen, and for a good reason. Hydrogen is the universe's most abundant element, making up roughly 90% of the atoms in a typical nebula. That's right, these giant cosmic clouds are mostly hydrogen, the same element that fuels stars and powers fusion reactions. Hydrogen is like the raw dough of the universe. It's light, simple, and incredibly versatile. In nebulas, hydrogen atoms can exist in different forms, neutral, ionized, or molecular, depending on the surrounding energy. The famous red glow in many emission nebulae actually comes from hydrogen gas being ionized by nearby stars. This hydrogen emits light at a specific wavelength called H-alpha, giving us that deep, almost surreal crimson hue. But hydrogen isn't just about color, it's the building block for stars. As gravity pulls hydrogen together inside dense regions of a nebula, temperatures and pressures rise until nuclear fusion ignites, creating a new star. So, when you look at a nebula like the Orion Nebula, you're not just seeing a cloud, you're seeing hydrogen in action, the fundamental ingredient for cosmic creation. Even in the quiet, dark parts of nebulas, hydrogen plays a subtle role. Molecular hydrogen, often invisible to the naked eye, hides in dense clouds, waiting for the right conditions to trigger star formation. In essence, hydrogen is the silent hero of the universe, omnipresent, essential, and quietly shaping galaxies over millions of years. Fact 22. Helium in nebulae. After hydrogen, helium is the second most abundant element in nebulas. It might not get the spotlight like hydrogen, but helium is vital in the story of stars and nebulae. Helium is created during the early stages of the universe, and it accumulates in nebulas along with hydrogen, quietly contributing to the chemistry of star formation. In the hottest regions of nebulae, helium can be ionized, emitting a soft glow that adds subtle colors to the overall scene. While not as visually dramatic as hydrogen's red emission, helium's presence is essential for the life cycle of stars. As new stars ignite, they fuse hydrogen into helium, gradually altering the chemical makeup of their surroundings. Helium also plays a role in the stability of stars. Without helium and other heavier elements present in nebulae, stars might burn differently. altering the balance between life and death in the universe. So, the next time you marvel at a nebula's beauty, remember, helium is quietly at work, shaping stars and contributing to the chemical story of space. Fact 23. Presence of carbon, oxygen and nitrogen. Nebulas aren't just hydrogen and helium, they're sprinkled with heavier elements like carbon, oxygen and nitrogen. These elements are crucial for making planets, dust grains, and even the complex molecules that eventually contribute to life. In many ways, these elements turn a nebula from a simple gas cloud into a cosmic laboratory. Carbon forms the backbone of organic molecules, oxygen adds reactive energy, and nitrogen is essential for complex chemical reactions. In emission nebulae, these elements can be ionized, producing different colors and textures. For example, oxygen often gives a nebula a greenish tint in photographs, while nitrogen enhances reds and oranges. These trace elements are more than just decoration. They influence the cooling of gas, the formation of stars, and the chemistry of new planetary systems. Essentially, carbon, oxygen, and nitrogen are the spices in the universe's recipe, making nebulae not just interesting visually, but vital chemically. Fact 24. Dust particles in nebulas aren't just made of gas, they also contain dust. Cosmic dust grains might be tiny, but they play a huge role. They scatter light, create shadows, and even help cool down gas clouds so that stars can form more efficiently. Dust also gives nebulas structure. It can create lanes, filaments, or dark silhouettes against glowing gas, as seen in the Horsehead Nebula. And without dust, reflection nebulae wouldn't exist. The dust reflects starlight to create those beautiful soft glows. Interestingly, dust grains contain elements like carbon, silicon, and iron. These particles eventually get incorporated into new stars, planets, and even comets, linking nebula dust to the material that might eventually make life possible. Fact 25. Ionized gases and their colors. One of the most mesmerizing things about nebulas is their colors, and much of that comes from ionized gases. When energetic stars emit ultraviolet light, they strip electrons from surrounding atoms, creating ions. These ions then emit light at specific wavelengths, producing the stunning reds, blues, and greens we see in photos. Hydrogen gives red and pink hues, oxygen gives greenish tones, and nitrogen contributes to deeper reds. This isn't just for show. The ionization tells astronomers about the temperature, density, and energy of the nebula. Every time you see a nebula glowing in vibrant colors, remember, it's a chemical dance, a story of light and energy, and a glimpse into the dynamic processes shaping our universe. Fact 26. Molecules. Found in nebulae, nebulas aren't just clouds of hydrogen and helium, they're full of molecules, some simple and some surprisingly complex. Think of molecules as tiny building blocks floating in space, waiting to be part of something bigger. The most common is molecular hydrogen, H2, which plays a central role in star formation. But beyond hydrogen, astronomers have discovered molecules like carbon monoxide, ammonia, water, and even more exotic ones like formaldehyde and methanol. These molecules are usually found in cooler, denser parts of a nebula, called molecular clouds. Inside these clouds, temperatures can be just a few tens of degrees above absolute zero, allowing molecules to form and persist. Without these molecular regions, stars might not form as efficiently, and the chemistry of the galaxy would be far less interesting. Studying these molecules also tells astronomers about the history and evolution of a nebula. For instance, the presence of complex carbon molecules suggests that a nebula has undergone processes that enrich it chemically, providing the raw materials not only for new stars but potentially for planets and life. It's fascinating to realize that in these distant clouds, the seeds of life's chemistry are floating silently, waiting for the right conditions to spark into something new. Fact 27. How gas composition affects nebula color. Ever wonder why some nebulas glow bright red, while others shimmer blue or green? The answer lies in their gas composition. Different elements emit light at specific wavelengths when energized, which creates the colors we see in photos or through telescopes. Hydrogen, the most abundant element, often gives emission nebulae their characteristic red and pink hues. Oxygen, when ionized, produces a greenish glow, while nitrogen contributes deep red shades. Helium and other trace elements can subtly modify the colour as well. It's not just about aesthetics. The colour tells astronomers about the nebula's chemical makeup, temperature, and energy sources. By analysing these colours through spectroscopy, scientists can determine which elements are present and in what quantities. In a way, every nebula is like a cosmic painting, with its palette dictated by chemistry and physics rather than paintbrushes. Fact 28. Nebula. Chemistry and complex molecules. Nebulas are more than clouds, they're chemical laboratories. Within their cold, dense regions, atoms collide, bond and form complex molecules. Carbon, oxygen and nitrogen atoms combine to create organic molecules that are surprisingly intricate for outer space. Some of these molecules are precursors to amino acids, the building blocks of life. These chemical reactions are slow, often taking thousands of years, but they set the stage for the formation of planets and the eventual emergence of life. In star-forming regions, the chemistry of the nebula influences the composition of the stars and planetary systems that will emerge from it. It's awe-inspiring to think that in these distant clouds, far beyond our reach, the universe is conducting experiments that may one day lead to life elsewhere. Nebulas are not just beautiful, they're dynamic, chemically active regions that shape the fate of entire solar systems. Fact 29. Tracing water in nebula's water is essential for life as we know it, and nebulae contain it too, albeit in icy or molecular form. Astronomers detect water in nebulae using radio and infrared telescopes, which can pick up the faint signals emitted by water molecules. Finding water in these clouds is exciting because it hints at how life-essential molecules are distributed throughout the galaxy. In star-forming regions, water ice coats dust grains, eventually becoming incorporated into forming planets, comets, and asteroids. In other words, the water in nebulas could one day end up on a planet, ready to nurture life. These discoveries connect the chemistry of distant clouds to our own origins. The same molecules floating in nebulae millions of light-years away were once part of the cosmic soup that created our solar system, linking us intimately to the wider universe. Fact 30. Nebula metallicity and star formation. In astronomy, metals refer to elements heavier than hydrogen and helium, carbon, oxygen, iron, and more. The metallicity of a nebula, or how rich it is in these elements, strongly affects star formation. Higher metallicity clouds cool faster because metals radiate energy efficiently, which allows the gas to collapse and form stars more easily. Conversely, metal-poor clouds may form fewer or more massive stars. This difference influences the types of stars and planetary systems that develop. Some of the first nebulas in the early universe had almost no metals, meaning the stars they formed were massive and short-lived. Today, nebulas like the Orion Nebula are rich in metals, giving rise to stars more similar to our Sun and increasing the chances of forming planets capable of supporting life. In essence, metallicity isn't just a chemical curiosity, it's a driver of cosmic evolution. It determines how efficiently stars form, what types of stars dominate a galaxy, and even the potential for habitable planets to emerge. Nebulas, it turns out, are not just passive clouds. They actively shape the next generation of stars and planets through their chemistry. Fact 31. Emission nebulas explained. When you see those stunning fiery red clouds in space, you're looking at an emission nebula. These are the show-offs of the nebula world, glowing brightly because their gases are energized by nearby hot stars. Imagine a star so powerful that it strips electrons from surrounding atoms, causing the gas to shine in colors ranging from deep crimson to soft pinks. The Orion Nebula is a classic example. Its central stars pump energy into the surrounding hydrogen gas, making it radiate light. But emission nebulae aren't just about beauty, they're active star factories. Within their glowing clouds, gravity pulls gas together, forming new stars. These newborn stars sometimes carve holes and shapes into the cloud, like tiny sculptors at work. Emission nebulae also tell astronomers a lot about chemical composition and temperature. Each colour corresponds to specific elements and conditions, turning these glowing clouds into cosmic textbooks. So, when you look at those red and pink swirls, you're witnessing a combination of light, chemistry and star formation. A celestial dance frozen in time. Fact 32. Reflection. Nebulas explained. Not all nebulas create their own light. Reflection nebulas are more subtle. They're like cosmic mirrors. Instead of glowing, they reflect the light of nearby stars, creating a soft bluish glow. Why blue? Because shorter wavelength blue light scatters more easily than red, just like our daytime sky. These nebulae often appear near young stars or clusters. The Pleiades cluster is surrounded by beautiful reflection nebulas, giving it a dreamy halo that makes it one of the most photographed star groups. While they lack the dramatic colours of emission nebulae, reflection nebulas are equally important. They reveal the structure of interstellar dust and help astronomers study the light and environment around young stars. In a way, reflection nebulae are gentle storytellers. They don't scream for attention, but quietly reveal the cosmic surroundings of their stellar neighbours. They're subtle, elegant, and vital pieces of the universe's puzzle. Fact 33. Dark nebulas. Explained dark nebulas are the mysterious shadows of the cosmos. Unlike their glowing cousins, these clouds are so dense that they block the light behind them, creating dark silhouettes in the starry sky. They're often called cosmic clouds of secrecy, because what's inside is hidden from visible light. The Horsehead Nebula is a perfect example. Its shape and depth are created by dense gas and dust, which absorb and scatter light, leaving a dramatic dark outline against glowing regions behind it. Despite appearing empty, dark nebulas are bustling nurseries. Inside, gravity can cause pockets of gas and dust to collapse, forming new stars that remain invisible until they ignite. Dark nebulas remind us that not all activity in the universe is obvious. Some of the most important processes, star birth, molecule formation, and chemical evolution, happen in the shadows, waiting for the right conditions to reveal themselves. Fact 34. Planetary nebulas. Explained planetary nebulas are deceptive by name. They have nothing to do with planets. Instead, they form when medium-sized stars like our Sun reach the end of their lives. As the star exhausts its fuel, it sheds outer layers of gas, creating a glowing shell around the remaining core. These shells often have intricate shapes, rings, spheres, or more complex forms sculpted by magnetic fields, stellar winds, or companion stars. The Ring Nebula is a famous example, with its elegant donut-like shape. Planetary nebulas are short-lived in cosmic terms, existing for only tens of thousands of years before dispersing into space. They're crucial for enriching the galaxy with heavier elements like carbon, nitrogen, and oxygen. These elements eventually get recycled into new stars, planets, and perhaps even life itself. Planetary nebulas are proof that even the quiet death of a star can be beautiful and productive. Fact 35. Supernova remnants. Supernova remnants are the spectacular aftermath of a massive star's explosive death. When a star runs out of fuel, its core collapses, triggering an explosion that can outshine an entire galaxy for a brief moment. The ejected material forms a nebula filled with energized gas and heavy elements. The Crab Nebula is the most famous supernova remnant, created by a star that exploded nearly 1,000 years ago. Supernova remnants are chaotic and turbulent, with shock waves compressing gas and dust, sometimes triggering the formation of new stars nearby. These remnants are more than just debris, they're cosmic recycling centers. They spread heavy elements across the galaxy, seeding future generations of stars and planets. Supernova remnants are a perfect example of destruction giving rise to creation, reminding us that in the universe, endings are often beginnings in disguise. Fact 36. Protoplanetary nebulas. Protoplanetary nebulas are fascinating transitional objects in space. They appear when a dying star has shed its outer layers but hasn't yet heated them enough to create a full planetary nebula. Think of it as the universe's version of a coming soon sign. Something spectacular is about to form, but it's still in progress. These nebulas often have intricate shapes like elongated shells, hourglass figures, or even delicate spirals. The patterns come from stellar winds, magnetic fields, or interactions with a companion star. Studying them helps astronomers understand the late stages of stellar evolution, showing the transformation from a red giant star to a planetary nebula. Protoplanetary nebulas are short-lived in cosmic terms, just a few thousand years, but they're essential for understanding how stars recycle their material into the galaxy. They're also visually stunning, often glowing faintly as dust reflects starlight, hinting at the brilliant planetary nebula they will become. Fact 37. H2 regions. H2 regions are some of the most energetic and active parts of the universe. These areas are filled with ionized hydrogen, hence the name H2, which glows brightly due to the radiation from nearby young, massive stars. Essentially, H2 regions are giant cosmic nurseries where new stars are actively forming. The Orion Nebula is one of the most famous H2 regions. In these clouds, ultraviolet light from massive stars strips electrons from hydrogen atoms, creating the brilliant red and pink glows that make emission nebulas so famous. H2 regions are dynamic and turbulent, with gas flowing, condensing and forming protostars. Studying H2 regions helps astronomers understand star formation rates, the chemical evolution of galaxies, and the interplay between young stars and their surroundings. They're a vivid reminder that the universe is never still. Cosmic birth is happening all around us, even if it takes thousands of years to unfold. Fact 38. Molecular clouds. Molecular clouds are the densest, coldest regions of nebulas, often called the cradles of star formation. These clouds are mostly molecular hydrogen, but they also contain helium, carbon monoxide, and other complex molecules. Because of their density, they block visible light, making them hard to see without infrared or radio telescopes. Inside these clouds, gravity slowly pulls gas and dust together, forming dense cores that eventually ignite into stars. Molecular clouds can span dozens or even hundreds of light years, holding enough material to create entire star clusters. Famous examples include the Orion Molecular Cloud Complex. These regions are like cosmic factories, quietly producing the next generation of stars. Without molecular clouds, the universe would have fewer stars, fewer planets, and far less opportunity for life to emerge. They're the silent, shadowy workhorses of the cosmos, hidden from plain sight but essential for creation. Fact 39. Bok globules. Bok globules are small, dark clouds within larger nebulas. They might only be a few light years across, but they are dense enough to hide new stars forming inside. Picture a tiny black speck floating in a glowing nebula. Inside, gravity is quietly at work, compressing gas and dust until a protostar ignites. These globules were first noticed by astronomer Bart Bok in the 1940s. They're often found in molecular clouds and H2 regions, acting as pockets of intense star formation. Despite their small size, Bok globules are crucial. They provide the perfect environment for isolated star formation, shielding developing stars from the turbulence around them. Bok globules are like nature's incubators, unassuming from the outside but harboring the next generation of stars. They remind us that in the universe, even the smallest, darkest places can be full of life and potential. Fact 40. Diffuse nebulas. Diffuse nebulas are the most widespread type of nebula, often forming extended clouds without a clear boundary. Unlike dense molecular clouds or compact planetary nebulas, diffuse nebulas spread out across light years, gently glowing or reflecting light from nearby stars. They can be emission nebulas, reflecting light, or even dark nebulas blocking background stars. Because of their large size, diffuse nebulas often contain regions of active star formation, as well as quieter areas where gas drifts slowly through space. The beauty of diffuse nebulas lies in their scale. They're reminders that the universe isn't just made of isolated objects. Stars, gas, and dust are interconnected, and these broad clouds reveal the galaxy's structure and composition. Observing diffuse nebulas helps astronomers map star-forming regions and understand how galaxies evolve over millions of years. Fact 41. The Orion Nebula. If you've ever looked up at the night sky and wondered where to spot a nebula with your own eyes, the Orion Nebula is the perfect starting point. Also known as M42, it sits in the Sword of Orion, the Hunter constellation, and even binoculars or a small telescope can reveal its faint glowing presence. It's the kind of cosmic wonder that makes you pause and realize the vastness and creativity of the universe. What makes Orion so remarkable is that it's a stellar nursery. Clouds of gas and dust here are slowly collapsing under gravity, forming hundreds of new stars. Some of these young stars are surrounded by protoplanetary disks, the earliest stages of planets coming into existence. This nebula is only about 1,350 light-years away, close enough that astronomers can study its star-forming activity in unprecedented detail. Its beauty isn't just in the science. The Orion Nebula glows in vivid shades of red from ionized hydrogen, with subtle hints of green from oxygen and even blue from scattered starlight. When you look at it, you're seeing a cosmic nursery in action, a chaotic, colourful and energetic region where stars are being born. It's a living example of the ongoing creativity of the cosmos, showing that even in the vast emptiness of space, new life, new stars, is constantly emerging. The Orion Nebula isn't just a pretty face in the sky. It's a laboratory of star formation, offering insight into how stars and planetary systems come to life. Each glowing region, each dark lane of dust, tells a story about gravity, gas, and energy interacting over millions of years. It's a glimpse at the universe's ongoing cycle of creation, and a reminder that even in the silence of space, extraordinary things are happening every day. Fact 42. The Eagle Nebula, Pillars of Creation. Few images in astronomy are as iconic as the pillars of creation in the Eagle Nebula. These towering columns of gas and dust stretch light years into space, looking almost like something from a fantasy movie, yet they are very real. Hubble's telescope captured this breathtaking view, and it has become a symbol of the beauty and mystery of star formation. Inside the pillars, dense pockets of gas collapse under gravity to form new stars. Meanwhile, ultraviolet radiation from nearby massive stars slowly erodes the columns, creating a delicate balance between destruction and creation. It's a cosmic paradox. Stars are being born even as their environment is being shredded. At about 7,000 light-years away, the Eagle Nebula offers a detailed look at these dynamic processes. Each pillar is a sculpted monument of gravity, radiation, and time. They illustrate how chaotic forces in space, winds, radiation, and gravity, combine to create both breathtaking visuals and the conditions necessary for star formation. The pillars of creation remind us that the universe is both violent and beautiful, with life emerging amid destruction. Fact 43. The Crab Nebula, M1. The Crab Nebula, or M1, is a supernova remnant and a vivid reminder of how violent cosmic events can produce both destruction and beauty. The explosion that created it was observed nearly 1,000 years ago in 1054 CE, leaving behind a glowing cloud of gas and dust that continues to expand at incredible speeds. At its centre lies a pulsar, a spinning neutron star emitting beams of radiation like a cosmic lighthouse. The Crab Nebula is rich in heavy elements, spreading the ashes of the exploded star into surrounding space. It's both visually stunning, with intricate filaments and glowing colours, and scientifically invaluable, helping astronomers understand supernova mechanics, neutron stars, and the life cycles of stars. Watching the Crab Nebula is like seeing the aftermath of a cosmic fireworks display frozen in time, a reminder that even death in space leaves a lasting legacy. Fact 44. The Carina Nebula. The Carina Nebula is one of the largest and most active star-forming regions in the southern sky. It contains several extremely massive stars, some tens or even hundreds of times the Sun's mass, driving intense radiation and stellar winds into the surrounding gas. These forces sculpt the nebula into filaments, cavities, and bright pillars. Eta Carinae, one of the most massive and unstable stars known, resides here and has erupted dramatically, adding to the nebula's complex structure. Its colourful clouds of hydrogen, oxygen, and nitrogen are not just pretty, they're evidence of star formation, chemical enrichment, and the galaxy's dynamic evolution. The Carina Nebula demonstrates how extreme stars influence their environment, showing the power and artistry of cosmic forces in action. Fact 45. The Horsehead Nebula. If you've ever seen a photo of a nebula and instantly recognized it, chances are it was the Horsehead Nebula. Its dark silhouette, perfectly shaped like a horse's head, stands out dramatically against the glowing clouds of hydrogen gas behind it, in the constellation Orion. It's one of those cosmic images that immediately captures the imagination, like looking at a familiar shape in the clouds. But this one is real, millions of times larger than anything on Earth. What makes the Horsehead Nebula so unique is that it's not an emission or reflection nebula. It's a dark nebula. That means it doesn't shine on its own. Instead, It's made of incredibly dense gas and dust that blocks the light coming from stars and glowing gas behind it. In essence, we see it because it is silhouetted against brighter regions of space. That contrast gives it its iconic shape and haunting beauty, a mysterious shadow in a colourful cosmic landscape. But the Horsehead is much more than just a striking visual. It's part of a larger molecular cloud, a vast stellar nursery where new stars are being born. Hidden inside those dark folds, pockets of gas are collapsing under gravity, forming the seeds of future stars. Its shape may look static in photographs, but in reality this nebula is alive with slow, ongoing activity. Over millions of years, the gas within it will continue to swirl, condense, and ignite into new stars. This nebula also teaches astronomers a lot about the hidden processes of the universe. Dark nebulae like the Horsehead are challenging to study because their dense material absorbs and blocks visible light. To peer inside, scientists use infrared and radio telescopes which can see through the dust. These observations reveal the internal structure of the cloud, the location of young stars, and even how the dust and gas interact with the radiation from nearby stars. It's a window into the quiet, behind-the-scenes work of star formation. There's a certain poetic aspect to it as well. The Horsehead Nebula reminds us that beauty in the universe isn't always about brightness or fireworks. Sometimes, the most fascinating processes happen in the shadows. While the glowing nebulae get a lot of attention for their colours and brilliance, it's the dark clouds, like this one, that nurture the next generation of stars, silently shaping the galaxy's future. Its iconic shape has made it a symbol in astronomy, appearing in countless images, books, and documentaries. But beyond the visuals, the Horsehead Nebula represents mystery, creation, and the hidden complexity of the cosmos. Even in places that appear dark and silent, the universe is bustling with activity, quietly crafting stars that will shine for millions or even billions of years. Next time you see a picture of this famous nebula, take a moment to appreciate not just its striking silhouette, but the invisible, intricate processes unfolding within, a shadowy cradle of cosmic creation. Fact 46. The Helix Nebula. If you've ever seen images of the Helix Nebula, you might have noticed its striking eye-like appearance. It almost seems to gaze back at us from across the cosmos. Located about 650 light-years away in the constellation Aquarius, the Helix Nebula is a planetary nebula, a dying star shedding its outer layers. At its heart lies a white dwarf, the remnant of a once brilliant star whose intense radiation lights up the surrounding gas in a mesmerizing spiral structure. What truly sets the Helix Nebula apart are the thousands of tiny comet-like structures scattered throughout, often called cometary knots. Each one is a dense clump of gas, some possibly the seeds of future stars or planets, while others are leftovers from the star's outer layers. These intricate knots give the nebula a textured, three-dimensional quality, reminding us that even a star's death is a process full of complexity and beauty. Astronomers have studied the helix extensively, not just for its appearance, but for the insights it provides into stellar evolution. Its layers reveal how stars shed mass in stages, while the distribution of gas and knots shows how matter interacts with radiation. Observing the Helix Nebula, whether through powerful telescopes or in stunning images, offers a vivid lesson in both cosmic impermanence and artistry. In tens of thousands of years the gas will disperse, leaving only the white dwarf behind, but for now, this nebula provides one of the closest and most detailed glimpses of a star's final stage, quietly spiraling in space, a beautiful, transient cosmic eye. Fact 47. The Lagoon Nebula. The Lagoon Nebula, or M8, is a massive stellar nursery, located about 4,000 light-years away in the constellation Sagittarius. Its name comes from the bright lagoon-like patch visible through telescopes, glowing like a cosmic oasis in the depths of space. Inside the Lagoon Nebula, young massive stars are forming at a remarkable rate. Their intense radiation ionizes surrounding hydrogen gas, creating brilliant pink and red hues. Dark dust lanes thread through the nebula, carving intricate patterns and adding depth to the glowing cloud. Within these lanes, protostars, newborn stars still shrouded in dense gas, begin their slow journey toward ignition. The Lagoon Nebula is a perfect example of how star formation shapes its environment. Stellar winds from massive young stars create cavities, compress neighbouring gas clouds, and trigger additional star formation. The nebula is in constant flux, a slow-motion ballet of gravity, radiation, and gas interacting to produce breathtaking beauty. Observing it is like watching a cosmic workshop where stars are continuously born, sculpted, and nurtured by their surroundings. This nebula not only demonstrates the drama of star formation, but also reminds us how energetic and dynamic the universe is. The Lagoon Nebula's glowing gas and dark lanes make it both scientifically valuable and visually captivating, a place where the cosmos reveals its creative power. Fact 48. The Rosette Nebula. The Rosette Nebula lives up to its name, resembling a blooming rose in the night sky. About 5,000 light-years away in the constellation Monoceros, it is an emission nebula, a vast cloud of hydrogen gas lit by dozens of young, massive stars clustered at its centre. These central stars are the architects of the nebula's glowing appearance. Their radiation energizes the surrounding gas, producing vibrant reds and pinks, and sculpts the cloud into cavities, pillars, and intricate shapes. The nebula's circular symmetry and delicate patterns make it a favourite for both astronomers and photographers. The Rosette Nebula is more than just beautiful. It's a textbook example of stellar feedback. The energy from young stars drives turbulence, compressing some gas into new stars while blowing other material outward. This continuous cycle of birth and influence demonstrates the dynamic relationship between stars and the nebulae that surround them. Ultimately, the Rosette Nebula is a living illustration of cosmic creation, where gas and stars dance together to shape a magnificent, evolving structure in space. Fact 49. The Cat's Eye Nebula. The Cat's Eye Nebula, or NGC 6543, is a planetary nebula about 3,000 light-years away in Draco, famous for its intricate and almost artificial-looking design. Concentric shells, jets, and knots of gas create the appearance of a cosmic eye, revealing the multiple stages of a star's death. Formed when a dying star expelled its outer layers, the cat's eye shows how planetary nebulae evolve over time. Each layer represents material ejected at a different moment, while the central white dwarf illuminates everything, revealing astonishing detail. Astronomers study it to understand how stars shed mass, how gas interacts with radiation, and how nebulae develop their stunning structures. Though small in the sky, its complexity is mesmerizing. Every filament and knot tells a story of stellar evolution, turning the Cat's Eye Nebula into a miniature universe in itself. Fact 50. The Trifid Nebula. The Trifid Nebula, or M20, is a spectacular combination of emission, reflection, and dark nebulae, located about 5,000 light-years away in Sagittarius. Its name comes from the three-lobed structure, split by dark dust lanes that create a trifurcated appearance. The red regions glow with ionized hydrogen, the blue sections reflect starlight, and the dark lanes are dense clouds that block light. Inside, new stars are forming, some hidden within the dusty lanes, making it a stellar nursery as well as a visual masterpiece. The Trifid Nebula illustrates the complexity of space, birth, reflection, and obscuration all happening within one region. It's a perfect example of the universe's creativity, showing how a single nebula can reveal multiple processes at work simultaneously. Fact 51. Nebula Sizes and Dimensions. Nebulas come in all shapes and sizes, and some are truly enormous. While a small planetary nebula might span just a few light-years, giant molecular clouds can stretch hundreds of light-years across. To put that into perspective, the Orion Molecular Cloud Complex is about 240 light-years long. That's mind-bogglingly vast, considering one light-year is nearly 6 trillion miles. The size of a nebula often depends on its type and origin. Supernova remnants can be relatively compact initially, but expand over thousands of years, while diffuse and molecular clouds naturally cover enormous areas of space. These vast dimensions mean that stars forming within a single nebula may be separated by dozens or even hundreds of light-years. Size also affects visibility. Smaller nebulae might require a telescope to observe, while giant emission or reflection nebulae can sometimes be faintly visible with binoculars under dark skies. Essentially, nebulas are cosmic landscapes, some like intimate gardens and others like sprawling galaxy-spanning plains of gas and dust. Fact 52. Nebula. Distances from Earth nebulas aren't all equally close. Some, like the Orion Nebula, are relatively nearby at about 1 in 350 light-years, while others lie thousands or even tens of thousands of light-years away in our Milky Way. For instance, the Carina Nebula is roughly 7,500 light-years away, and more distant nebulas in other galaxies are millions of light-years distant. Distance affects how we observe nebulas. Nearby clouds allow astronomers to study star formation in incredible detail, while distant nebulae might only appear as faint, colourful smudges. Measuring distances involves techniques like parallax, spectroscopy, and comparing brightness to known stars. Understanding these distances is crucial because it tells us how far light has travelled and allows us to gauge a nebula's true size and energy output. In short, when you see a nebula in a telescope image, you're often looking at light that left the cloud centuries, even millennia ago. It's a view into the past, offering a cosmic time machine that spans enormous distances. Fact 53. Nebula densities. Despite their enormous size, nebulas are surprisingly diffuse. Most have densities far lower than even the best vacuums we can create on Earth, sometimes only a few hundred or a few thousand atoms per cubic centimetre. Compare that to Earth's atmosphere, which has roughly 1 billion trillion atoms in the same volume. Densities vary depending on the type of nebula. Molecular clouds are the densest, allowing star formation to occur, while diffuse or emission nebulae are far thinner. Density determines how gas and dust behave. Higher density regions collapse under gravity to form stars, while low density areas drift and slowly disperse. Understanding density is critical for astronomers because it controls star formation rates, chemical reactions, and the stability of the cloud. Nebulas might look solid in telescope images, but in reality they are mostly empty space with just enough material to shape the cosmos. Fact 54. Temperatures in nebulas. Temperatures in nebulas vary wildly depending on the type. Molecular clouds, where stars are born, can be incredibly cold, just a few tens of degrees above absolute zero. These low temperatures allow complex molecules to form and survive in space. In contrast, emission nebulae can be thousands to tens of thousands of degrees heated by the radiation of nearby hot stars. Supernova remnants are even hotter, with shock waves driving temperatures into millions of degrees. Temperature affects the nebula's colour, density, and ability to form stars. So when you see a glowing nebula, remember that it's not just a cloud of gas. It's a dynamic environment, sometimes freezing cold, sometimes searingly hot, all at the same time. Fact 55. Lifespan of a nebula. Nebulas are like fleeting clouds in the sky, but on a cosmic scale they live surprisingly short lives. Take planetary nebulas, for instance. They last only tens of thousands of years, a blink in the universe's timeline. Molecular clouds, which are the cradles of star formation, endure longer, often millions of years. Even supernova remnants, which are the spectacular leftover shells of exploded stars, only exist for thousands to tens of thousands of years before dispersing into space. It's fascinating to think about. To us, these durations feel unimaginable, yet in the grand scheme of a galaxy's life, which spans billions of years, nebulas are ephemeral. Their lives are measured not in centuries or millennia, but in moments of cosmic significance. A nebula's life begins in one of two ways. Either material is ejected from a dying star, like in a planetary nebula, or it accumulates in a dense patch of interstellar gas, forming a molecular cloud. During its life, it may form new stars, serve as a chemical laboratory, or simply drift through the galaxy, shaped by gravity and nearby stellar activity. Eventually, its material disperses, some blown away by stellar winds, some incorporated into new stars and planets, and some slowly diffusing back into the interstellar medium. What's poetic is that every nebula, no matter how short-lived, leaves a lasting impact. The Orion Nebula, for example, will one day fade, but the stars it birthed will continue to shine for millions or even billions of years. Each nebula is a fleeting chapter in the story of the cosmos, a beautiful cloud that exists just long enough to create life, chemically and physically, before fading into the larger tapestry of the universe. In essence, the lifespan of a nebula reminds us that even brief moments can be monumental. In their ephemeral glow, they tell tales of birth, evolution, and cosmic transformation, proof that in the universe, beauty and significance do not always demand permanence. Fact 56. Brightness and luminosity. When we gaze at a nebula, the first thing that captures our attention is often its brightness. But there's a subtle distinction here. The brightness we see from Earth is not necessarily the nebula's true energy output. That's where luminosity comes in, the total energy a nebula emits per second. Unlike apparent brightness, which dims with distance, luminosity gives astronomers an accurate measure of a nebula's power. Emission nebulae are the true powerhouses. Energized by nearby hot stars, they shine with incredible intensity. The Orion Nebula, for example, glows with the combined energy of thousands of suns, yet even with all that power, it appears as a faint smudge in the night sky because it is about 300 light-years away. Reflection. Nebulae, on the other hand, don't generate their own light. They shine by scattering starlight, which makes them less luminous but no less captivating. Brightness and luminosity also depend on other factors: the density of gas, the number of stars, and how much dust is blocking or absorbing light. In dense regions, light may be partially obscured, while sparse areas may appear dimmer even if the intrinsic luminosity is high. By studying these variations, astronomers can infer star formation rates, the chemical makeup of the nebula, and even its size. Every glow, flicker, and shimmer in a nebula tells a story. The brightness is not just a visual spectacle, it is a record of energy, activity, and the complex interplay between stars and gas. Observing luminosity allows us to peer behind the colours and see the universe's dynamic processes at work, providing clues to both current activity and the nebula's past. Fact 57. Gas pressure variations. Nebulas are far from being uniform clouds floating passively in space. Inside them, gas pressure varies dramatically, creating a complex dynamic environment. High-pressure zones compress material, often sparking star formation, while low-pressure areas allow the cloud to expand or drift, changing the nebula's shape over time. What causes these pressure differences? A variety of forces are at play. Gravity pulls material inward, trying to collapse the cloud into denser clumps. Radiation from nearby hot stars exerts outward pressure, while shock waves from supernovae can slam into clouds, creating turbulence and compression. Even collisions with other clouds can generate localized high-pressure regions. Emission nebulae showcase this beautifully. The intense ultraviolet radiation from massive stars creates pockets of high pressure that push gas outward, forming cavities, filaments, and arcs. In molecular clouds, regions with slightly higher pressure may become protostars, slowly collapsing under gravity until nuclear fusion ignites. Gas pressure variations are crucial because they dictate when and where stars form. A small fluctuation in pressure can transform a calm patch of gas into a thriving star-forming hub. Turbulence, radiation, gravity, and pressure all combine to make nebulas vibrant, ever-changing laboratories of cosmic physics, demonstrating that the universe is rarely still, even in what looks like quiet clouds of gas. Fact 58. Magnetic fields in nebulae. Magnetic fields are invisible architects of nebulas, quietly shaping gas and dust in ways that are often overlooked. They thread through molecular clouds, guiding charged particles and influencing star formation. In some cases, they even help create stunning filamentary structures that stretch for light years. In dense molecular clouds, magnetic fields can slow down the collapse of gas, regulating how quickly stars form. They can align dust grains, affecting how light scatters and polarizes as it passes through the nebula. Observing these fields requires careful measurements of polarized light, but the information is invaluable, revealing hidden forces at work in star-forming regions. Magnetic fields act like cosmic sculptors. They don't generate light, they don't move matter directly, yet their influence is profound. By subtly directing the motion of gas and dust, they affect the shape, density, and evolution of a nebula. Without them, the intricate filaments, arcs, and patterns we see in clouds like the Orion Nebula or the Eagle Nebula would look very different. In short, magnetic fields are unseen but essential players in the life of nebulas. They remind us that the universe's beauty is often guided by invisible forces, quietly orchestrating the dance of matter and energy. Fact 59. Turbulence in nebula. Gases. Nebula gases are far from calm. Turbulence, the chaotic, unpredictable motion of gas within the cloud, is a central feature of these cosmic structures. Shockwaves from supernovae, powerful stellar winds and collisions between clouds stir up the gas, producing swirling patterns, filaments, and knots that are both visually stunning and scientifically fascinating. Turbulence is a double-edged sword. On one hand, it can disrupt star formation by dispersing gas and preventing collapse. On the other hand, it compresses material in pockets, triggering new stars to ignite. It also mixes chemical elements, spreading heavy atoms forged in previous generations of stars into regions where new stars will form. Without turbulence, nebulas would be static, uneventful clouds. Instead, turbulence injects energy, motion, and unpredictability, shaping the very processes that lead to stellar birth and chemical enrichment. It's like the heartbeat of a nebula, chaotic, irregular, yet essential for the life of stars and the evolution of the galaxy. Fact 60. Nebula motion in galaxies. Nebulas aren't just floating clouds of gas and dust. They're active travelers, moving through the galaxy like cosmic ships riding invisible currents. Every nebula orbits the center of its host galaxy, influenced by gravity, magnetic fields, and interactions with other clouds. This motion is far from random. It's part of the intricate dance of stars, gas, and dark matter that shapes galaxies over billions of years. In spiral galaxies like the Milky Way, nebulae often follow the spiral arms, which act like highways of star formation. As clouds move along these arms, they experience compression from density waves, regions where the galactic material is slightly denser. This compression can trigger star formation, as pockets of gas collapse under gravity to ignite new stars. That's why many of the galaxy's stellar nurseries are concentrated along spiral arms. Moving clouds encounter these density waves and burst into activity. But spiral arms aren't the only influence. Nebulas can collide with other clouds, or experience shock waves from nearby supernovae. These interactions can push clouds off their original paths, compress gas, or even fragment a nebula into smaller pieces. Magnetic fields thread through these clouds as well, subtly guiding the motion of charged particles and helping shape the nebula's structure. In this sense, a nebula's movement is a story of both external forces and internal dynamics working together. Observing nebula motion is also a powerful tool for astronomers. By tracking the velocity and direction of gas clouds, scientists can infer the structure of the galaxy itself. For instance, measuring how nebulae orbit the galactic center helps determine the mass of the Milky Way, including its invisible dark matter. Motion tells us where gas is flowing, which regions are forming stars, and even how spiral arms maintain their shape over millions of years. There's a poetic side to it too. A nebula isn't just a static, beautiful image in a telescope. It's a participant in the galaxy's life, carrying gas, dust, and chemical elements as it journeys through space. The hydrogen, helium, and heavier elements within a nebula are constantly moving, sometimes forming stars along the way, sometimes mixing into the interstellar medium, seeding future generations of stars and planets. In essence, nebula motion reminds us that the universe is alive with activity. Clouds that seem serene in photos are in constant motion, shaped by gravity, radiation, turbulence, and magnetic fields. Each nebula's path contributes to the ongoing story of its galaxy, driving the cycles of star formation, stellar death, and cosmic recycling. They are not just passive clouds. They are dynamic, moving laboratories of the cosmos, quietly shaping the universe as they glide through space. Watching a nebula move might take millions of years, but its motion is part of the rhythm of the galaxy, an invisible dance connecting matter, energy, and time across the stars. Fact 61. Nebulas as stellar nurseries. One of the most captivating roles of nebulas is their function as stellar nurseries. Picture a giant cloud of gas and dust floating in space, quiet and serene at first glance, but inside, gravity is at work, slowly pulling material together to form new stars. These clouds, nebulae, are the cradles of starbirth, and without them, the universe would have far fewer stars. In these stellar nurseries, conditions must be just right. The cloud needs to be dense enough for gravity to overcome internal pressure, but not so turbulent that the material gets dispersed. Once pockets of gas begin to collapse, they heat up, forming protostars. Over millions of years, these protostars ignite nuclear fusion in their cores, officially becoming stars. Nebulas as stellar nurseries are not uniform. Some regions are dense and chaotic, forming clusters of stars, while others are quieter, producing stars more slowly. Observing these clouds gives astronomers a glimpse into the earlier stages of star life, showing how the universe constantly renews itself. In every colourful nebula, there's a hidden story of creation unfolding, a cosmic nursery where stars take their first breaths. Fact 62. Protostars. Forming in nebulas. Inside nebulae, the drama of star formation begins with protostars. A protostar is essentially a baby star, formed when a dense clump of gas and dust collapses under gravity. These early stars are surrounded by swirling material, sometimes forming disks that could eventually become planets. As the gas collapses, it heats up, emitting infrared radiation even before nuclear fusion begins. This means protostars are often invisible in visible light, hidden within their dusty cocoons, but astronomers can detect them with infrared telescopes. Observing protostars helps us understand the first steps in stellar evolution, how stars gather mass, how disks form, and how radiation begins to shape the surrounding nebula. Every protostar is a promise. In time, it may become a small, sun-like star or a massive, brilliant star that lights up its region. Watching them form in nebulas is like peering into a cosmic maternity ward, where the universe gives birth to its most fundamental building blocks, stars. Fact 63. Triggered star formation. Star formation isn't always a slow, quiet process. Sometimes it's triggered by external forces. Shockwaves from supernovae, collisions with other clouds, or radiation from massive nearby stars can compress gas in a nebula, causing new stars to form rapidly. Triggered star formation is a kind of cosmic domino effect. One massive star forms, emits radiation and stellar winds, and pushes nearby gas into denser regions. Those regions collapse faster, producing more stars. This chain reaction can create clusters of stars and sculpt beautiful structures in the nebula, like the pillars of creation in the Eagle Nebula. This process shows how interconnected the universe is. The death of one star can trigger the birth of many others, highlighting a cosmic cycle of destruction and creation that shapes galaxies over millions of years. Fact 64. Massive star formation in nebula. Not all stars in a nebula are created equal. Massive stars, tens or hundreds of times the Sun's mass, form in dense, turbulent regions. These stars are powerful engines of energy, emitting intense ultraviolet radiation and strong stellar winds that shape the surrounding nebula. Massive star formation is rare but dramatic. Their energy can blow cavities in the nebula, trigger further star formation nearby, and enrich the cloud with heavy elements. These stars live fast and die young, often exploding as supernovae within a few million years. Watching massive star formation gives astronomers insight into galaxy evolution, chemical enrichment, and the dynamic interplay between stars and their birth clouds. In other words, massive stars are both creators and destroyers, leaving a lasting imprint on their nebulae and beyond. Fact 65. Planet formation. Within nebulae. Nebulas don't just produce stars, they also set the stage for planets. Around many newborn stars, rotating disks of gas and dust form, called protoplanetary disks. Over millions of years, dust grains collide, stick together, and gradually build up into planetesimals, the seeds of planets. These disks often inherit the chemical richness of their parent nebula, containing water, carbon, oxygen, and other elements essential for life. Some disks will form rocky planets like Earth, while others may produce gas giants like Jupiter. Observing these disks in nebulae allows astronomers to study the earlier stages of planetary formation and even speculate about potential habitability. Nebulas are, in a sense, cosmic nurseries not just for stars but for entire planetary systems. Each new star emerging from a nebula might carry with it the ingredients for planets, and possibly the conditions for life, to form. Fact 66. Role of turbulence in star formation isn't a smooth, orderly process. Nebulae are turbulent, chaotic places. Gas and dust swirl unpredictably, forming waves, filaments, and clumps. This turbulence is crucial because it compresses pockets of material, creating the dense regions where stars can ignite. Without turbulence, gas might remain too diffuse, never collapsing into stars. On the other hand, excessive turbulence can disrupt star formation, dispersing material before gravity can do its work. In many ways, turbulence is like a cosmic sculptor, simultaneously stirring the cloud and shaping the locations where stars will form. Astronomers study these turbulent motions using spectroscopy, observing how gas moves and interacts within a nebula. Understanding turbulence helps explain why some regions of a nebula are teeming with stars while others remain quiet. In essence, the chaos inside a nebula is what gives birth to order, the stars. Fact 67. Star clusters. Born in nebulae. Nebulae are rarely home to just a single star. Often they give birth to entire clusters of stars, sometimes containing hundreds or thousands of young stars packed into a relatively small space. These clusters form from massive molecular clouds, where turbulence and gravity work together to condense gas into many protostars at once. Star clusters reveal the story of a nebula's past. Observing them allows astronomers to study how stars of different sizes evolve in close proximity, and how massive stars influence their neighbours. Some clusters, like the Trapezium in the Orion Nebula, are iconic examples of stars born in tight-knit groups, illuminating their surroundings and sculpting the remaining gas. Clusters also help us understand the dynamics of galaxies. Over time, stars may drift apart or remain bound by gravity, but their shared origin in a nebula remains a key clue about the galaxy's star-forming history. Fact 68. How massive stars affect nebula. Evolution. Massive stars are the rock stars of a nebula. They're bright, energetic, and impossible to ignore. Their intense radiation and stellar winds blow away surrounding gas, carving cavities, shaping filaments, and sometimes triggering new star formation nearby. These stars live fast and die young, often exploding as supernovae that inject energy and heavy elements back into the nebula. This feedback can dramatically alter the nebula's structure, creating both destruction and opportunity. Areas once dense enough to form stars may be dispersed, while other regions are compressed, accelerating star formation. Massive stars are essentially architects of their nebulae. Their presence dictates how the cloud evolves, where stars form, and how chemical elements are recycled into the next generation of stars and planets. Fact 69. Nebula. Feedback in galaxies. The influence of nebulae extends beyond their own boundaries. Through processes like star formation, stellar winds, and supernovae, nebulae contribute to the feedback mechanisms that shape entire galaxies. When a nebula's stars energize their surroundings, they can trigger new waves of star formation, regulate gas density, and even influence galactic rotation and structure. This feedback is vital for maintaining the balance between star formation and gas availability in galaxies. In other words, nebulae aren't just passive clouds. They're active participants in the life of galaxies, linking the birth of stars to the broader evolution of cosmic structures. They remind us that small clouds of gas can have galaxy-wide consequences over millions of years. Fact 70. Star life cycles. Starting in nebulas. Every star's story begins in a nebula. From a tiny clump of gas and dust, a protostar emerges, grows, and eventually ignites nuclear fusion. Over millions to billions of years, the star lives out its life, whether quietly as a sun-like star or dramatically as a massive star ending in a supernova. The nebula sets the stage. Its composition determines the star's chemical makeup, while its density and turbulence influence how quickly and where the star forms. Even after a star leaves its birth cloud, the elements it produces during its life, through fusion or supernova, are returned to the interstellar medium, enriching future nebulas and continuing the cycle. In this way, nebulae are both the cradle and the classroom for stars. Every star we see in the night sky carries the story of its nebular origins, connecting us directly to the life cycles of the universe. Fact 71. Why nebulas glow. Have you ever wondered why nebulas glow so beautifully in space images? The answer lies in energy and light. Some nebulas, like Emission Nebulum, glow because their gases are energized by nearby stars. Ultraviolet light from hot, young stars excites the atoms in the gas, causing them to emit light. Hydrogen, the most common element in nebulas, glows bright red when excited, giving many nebulae their characteristic crimson hue. Other nebulas shine by reflection, bouncing light from nearby stars. Dust particles scatter shorter wavelengths like blue light more efficiently, producing the bluish glow often seen in reflection nebulae. Even dark nebulae glow in a sense, not with visible light but with the absorption of light, creating dramatic silhouettes against brighter backgrounds. Essentially, nebulae are cosmic canvases. Their colours and brightness depend on what's inside them and what stars surround them. Observing their glow is like reading a story of energy, chemistry, and the processes shaping our galaxy. Fact 72. Red emission nebulae. Red emission nebulae are the showstoppers of the cosmic world. The red colour comes mainly from hydrogen gas being energised by the intense ultraviolet radiation of nearby massive stars. When hydrogen atoms recombine after being ionised, they emit light in the red part of the spectrum, a process called H-alpha emission. These nebulae are often bustling stellar nurseries. The Orion Nebula is a perfect example, where the red glow signals active star formation. As stars ignite, their radiation lights up the surrounding hydrogen gas, revealing the cloud's structure and composition. The red emission isn't just beautiful, it's informative. By analysing the intensity and colour of the glow, astronomers can determine the temperature, density, and chemical makeup of the nebula. In other words, each crimson swirl is both a visual marvel and a cosmic data source. Fact 73. Blue reflection. Nebulae. Blue reflection nebulae are like cosmic mirrors. They don't generate their own light. Instead, they reflect the light of nearby stars. Dust particles scatter blue light more efficiently than red light, producing the characteristic bluish hue. This is the same reason Earth's sky appears blue during the day. The Pleiades cluster is a famous example. The stars illuminate surrounding dust clouds, creating a soft, ethereal glow that seems to shimmer in space. While less dramatic than red emission nebulae, reflection nebulae are essential for studying interstellar dust. They reveal the distribution, size, and composition of dust grains, which are critical for star and planet formation. Blue reflection nebulae remind us that light in space doesn't just shine, it interacts, bounces, and sculpts the clouds around it, creating delicate cosmic artistry. Fact 74. Dark nebula silhouettes. Not all nebulas glow. Dark nebulae, such as the Horsehead Nebula, appear as dramatic silhouettes against brighter backgrounds. These clouds are dense with dust and gas, absorbing and blocking light from stars or emission nebulae behind them. The darkness isn't emptiness, it's packed with material, sometimes forming stars hidden from view. Observing these silhouettes gives astronomers clues about the density, shape, and composition of the cloud. Dark nebulae act as cosmic shadow puppets, sculpting striking patterns while nurturing the next generation of stars within their opaque folds. They show that even in darkness, nebulas are alive with activity, shaping the universe in ways we often can't see directly. Fact 75. Infrared observations of nebulas. Many details of nebulas are invisible in visible light. Infrared telescopes allow astronomers to peer through dust and gas, revealing hidden stars, protostars, and structures within the clouds. Infrared light can penetrate dense regions, showing areas of star formation that would otherwise be invisible. For instance, the Orion Nebula glows brightly in infrared, revealing dozens of protostars still wrapped in their dusty cocoons. Infrared observations also detect complex molecules, including water and organic compounds, offering insights into the chemical evolution of the nebula. Infrared is like giving us night vision for space. It unveils the hidden activity within nebulas, showing that beneath their glowing or dark exterior, there's a bustling, dynamic environment of starbirth and chemical complexity. Fact 76. Ultraviolet effects on nebula gas. Ultraviolet, UV, radiation from hot young stars has a dramatic effect on the gas in nebulae. This high-energy light ionizes atoms, stripping electrons from hydrogen, helium, and other elements. The process energizes the gas, causing it to glow in brilliant colors, often red for hydrogen and green or blue for oxygen. UV radiation doesn't just create a beautiful light show, it shapes the nebula itself. It heats gas, generates pressure differences, and drives stellar winds, sculpting pillars, cavities, and filaments. For example, in the Eagle Nebula, UV radiation from massive stars erodes the pillars of creation, slowly exposing newly forming stars within. Without UV radiation, many nebulae would remain dark, cold clouds. It's this invisible energy that transforms a quiet gas cloud into a vibrant, dynamic stellar nursery. In essence, UV light is the artist and the architect, simultaneously illuminating and shaping the cosmic landscape. Fact 77. X-ray emissions from nebulae. While visible light shows us the colourful beauty of nebulae, X-ray observations reveal their high-energy side. Supernova remnants and regions around massive stars emit X-rays, produced by shockwaves heating gas to millions of degrees. The Crab Nebula is a famous example. Its central pulsar accelerates particles to nearly the speed of light, creating an X-ray glow that's invisible to our eyes but detectable by space telescopes like Chandra. X-ray emissions help astronomers study extreme processes, stellar explosions, magnetic fields, and particle acceleration, offering a different perspective on nebular activity. X-rays reveal that nebulae aren't just tranquil clouds. They are arenas of violent, energetic events that shape stars, gas, and even the chemistry of the interstellar medium. Fact 78. Spectroscopy of nebula. Light. Spectroscopy is like a decoder ring for light. By splitting nebula light into its component colours, astronomers can determine which elements are present, their temperatures, densities, and even motion. Each element produces a unique spectral signature, like a fingerprint, allowing scientists to read the chemical story of the nebula. For example, bright emission lines in red correspond to hydrogen, green to oxygen, and blue to helium. Spectroscopy can also reveal subtle shifts in wavelength due to the Doppler effect, telling us whether gas is moving toward or away from us. This technique transforms nebulas from pretty pictures into laboratories of physics and chemistry, giving insight into star formation, gas dynamics, and the evolution of the universe. Fact 79. How telescopes capture nebula. Colours and nebula images are often stunning, bursting with vivid reds, blues, and greens. But capturing these colours requires more than just a telescope. It often involves filters and long-exposure imaging. Filters isolate specific wavelengths of light, like H-alpha for hydrogen or O3 for oxygen, allowing astronomers to map the distribution of elements. Combining filtered images can create the vibrant composite pictures we see online. While some colours are enhanced for clarity or artistic effect, they still represent real physical processes. This is why telescopes like Hubble have provided images that are both scientifically accurate and visually breathtaking. By translating invisible light into colours we can perceive, telescopes let us see the nebula's chemical composition and structure in vivid detail, revealing the universe's hidden artistry. Fact 80. The role of ionized hydrogen. Ionized hydrogen, or HAR, is perhaps the most important player in nebulae. When hydrogen atoms are energized, they emit a specific red light called He-alpha, which dominates many emission nebulae. This red glow is the signature of star-forming regions, marking where gas is excited by nearby hot stars. HAR also serves as a diagnostic tool for astronomers. By measuring its intensity, they can determine gas density, temperature, and star formation rates. Observing H-alpha emissions reveals where stars are being born and how the surrounding cloud evolves. In short, H-alpha is the heartbeat of emission nebulae. It's the glowing signature of activity, the light that tells the story of creation, and the key to understanding the interplay between stars and the clouds that birthed them. Fact 81. Nebulas in the Orion Arm. The Orion Arm is our cosmic neighbourhood, a spiral arm of the Milky Way that contains our Sun. It's a region rich in nebulae, making it an ideal laboratory for studying star formation. Among its most famous nebulas is the Orion Nebula, M42, a stellar nursery visible even with binoculars. Nebulas in the Orion Arm are relatively close, ranging from 1 to 300 to 2,000 light-years away, which allows astronomers to study their structures in detail. These clouds are diverse. Some are massive molecular clouds forming clusters of stars, while others are smaller, denser planetary nebulae left by dying stars. Being in the Orion Arm means we are essentially living amid these cosmic clouds. Observing them provides not just breathtaking images, but crucial insight into how stars, planets, and even potential life-bearing systems form in our corner of the galaxy. Fact 82. Nebulas in the Carina-Sagittarius arm. The Carina-Sagittarius arm is one of the Milky Way's most active star-forming regions, home to giant nebulae like the Carina Nebula and the Lagoon Nebula M8. These clouds are massive, colourful and dynamic, often containing young, massive stars that shape the gas and dust around them. Nebulas here are farther away than those in the Orion arm, typically 5,000 to 8,000 light-years, but their size and activity make them stand out. Massive stars in these clouds emit intense ultraviolet radiation, creating ionized gas regions and sculpting intricate filaments. Studying these nebulae helps astronomers understand how star formation scales in more active parts of the galaxy. They also provide a vivid example of how spiral arms concentrate gas, fostering the birth of thousands of stars over millions of years. Fact 83. Nebulas. Near the galactic centre. The Milky Way's centre is a bustling hub, crowded with stars, gas and dust. Nebulas near the galactic centre face intense radiation, strong gravitational forces and frequent supernova explosions. This makes star formation both more challenging and more dramatic. The central nebulae are often dense molecular clouds, rich in heavy elements produced by generations of previous stars. Observing them is tricky because the region is obscured by dust in visible light, so astronomers rely on infrared and radio telescopes to see inside. Nebulas in this region teach us how stars form under extreme conditions. They are laboratories for studying the interplay of gravity, radiation, and magnetic fields in one of the galaxy's most energetic environments. Fact 84. Nebulas in the Perseus arm. The Perseus arm lies beyond the Orion arm, containing numerous star-forming regions and nebulae. These clouds are generally more massive and extended than those nearby, providing fertile ground for the birth of both small and massive stars. Famous examples include the California Nebula, a long filamentary emission nebula, and various molecular clouds rich in gas and dust. Because of their distance, studying these nebulae often requires large telescopes and sensitive detectors, but they reveal crucial information about star formation across the galaxy. By observing nebulas in the Perseus arm, astronomers can compare local star-forming activity with more distant regions, helping to understand how galactic structure influences stellar evolution. Fact 85. Nebulas in the outer Milky Way. Even far from the galactic centre, the Milky Way hosts nebulae that continue the cycle of starbirth. These outer arm nebulae are generally less dense and have lower metallicity than inner arm clouds, meaning they contain fewer heavy elements. This affects the type of stars formed and the evolution of the nebula itself. Massive star formation is less common, and the gas clouds tend to evolve more slowly. Yet these outer nebulas are crucial for understanding how galaxies maintain star formation across vast distances. Studying them also helps astronomers trace the overall structure of the Milky Way, mapping spiral arms and interstellar material far from the centre. Even at the galaxy's edge, nebulas continue to remind us that star formation is a universal process. Fact 86. How nebula distribution affects star formation. Where a nebula is located in a galaxy can significantly influence how stars form. Nebulas are not evenly scattered. They tend to cluster along spiral arms, around star-forming regions and near massive stellar clusters. This uneven distribution matters because denser regions allow gas to collapse more readily, giving birth to more stars. In spiral galaxies like the Milky Way, spiral arms act like cosmic highways for gas and dust. Nebulas travelling through these arms experience compression, which triggers star formation. Conversely, isolated clouds in quieter parts of the galaxy form stars more slowly. Distribution also affects the types of stars formed. Dense clusters can produce massive stars that live fast and die young, while more isolated clouds often produce smaller, longer-lived stars. In essence, the location of a nebula is like real estate. Prime neighbourhoods produce more stars while lonely corners form stars more slowly. Fact 87. Dark nebula regions in our galaxy. Dark nebulae are some of the most intriguing features in the Milky Way. These dense clouds of dust and gas appear as opaque silhouettes against brighter backgrounds, hiding star formation within their folds. Famous examples include the Horsehead Nebula and the Coalsack Nebula. Though they appear empty, dark nebulae are bustling sites of stellar birth, their density shields forming stars from harsh radiation allowing protostars to develop safely. By mapping these regions, astronomers can identify future stellar nurseries before the stars even emerge in visible light. These clouds also reveal the galaxy's structure. Concentrations of dark nebulae help trace spiral arms and the distribution of molecular material, showing where star formation is ongoing and where it might occur next. Fact 88. Bright nebula clusters. Bright nebulae often gather in clusters, forming dazzling stellar nurseries visible across vast distances. These clusters include multiple emission or reflection nebulae, illuminated by the combined light of massive young stars. The Orion Nebula cluster is a prime example, with dozens of bright young stars energizing the surrounding gas. Similarly, the Carina Nebula hosts clusters of massive stars whose radiation sculpts the nebula's intricate filaments and cavities. Clusters are fascinating because they show the collective effect of stars on their environment. The energy from multiple stars can trigger further star formation, blow cavities in the gas, and enrich the surrounding medium with heavy elements. Observing bright nebula clusters is like watching a bustling cosmic city, where new stars are constantly born and raised. Fact 89. Mapping Milky Way. Nebulas. Mapping the distribution of nebulas in our galaxy is a major astronomical endeavour. Using radio, infrared, and optical surveys, astronomers can trace molecular clouds, emission regions, and dark nebulae across the Milky Way. These maps reveal patterns. Nebulas cluster along spiral arms, concentrate near massive stellar clusters, and appear more sparsely in the outer regions of the galaxy. Mapping helps scientists understand star formation rates, galactic structure, and the flow of gas and dust over millions of years. By combining observations at different wavelengths, astronomers can see both the glowing gas of active nebulae and the hidden dark clouds, creating a comprehensive picture of our galaxy's star-forming regions. Fact 90. Observing nebulas from Earth. Despite being light years away, many nebulas can be observed from Earth with the right equipment. Emission and reflection nebulae are visible through telescopes or binoculars under dark skies, while dark nebulae appear as dramatic silhouettes against star fields. Astronomers use different filters to isolate specific wavelengths, such as H-alpha for hydrogen, to enhance the nebula's features. Infrared and radio telescopes reveal structures hidden by dust, making invisible star-forming regions visible. For casual stargazers, some nebulas, like the Orion Nebula, are even visible to the naked eye. Observing nebulas from Earth connects us directly to the life cycles of stars, letting us witness cosmic birthplaces that are thousands of light years away. Fact 91. Nebulas in Andromeda. The Andromeda Galaxy, our nearest spiral neighbour, is home to countless nebulas scattered across its vast disk. Just like in the Milky Way, these clouds of gas and dust are active sites of star formation. Observing them is both a challenge and a thrill for astronomers, as Andromeda lies about 2.5 million light-years away. Among its nebulae, emission clouds shine brightly in H-alpha light, highlighting regions where young, hot stars energize the gas around them. Reflection. Nebulae also scatter starlight, creating bluish patches that reveal the presence of dust. Studying these nebulae allows scientists to compare star formation in Andromeda with our own galaxy, giving insights into how spiral galaxies evolve over time. Andromeda's nebulae remind us that star formation is a universal process. Even millions of light-years away, we can trace the same cosmic cycles of birth, growth, and eventual stellar death, witnessing how neighbouring galaxies echo the life patterns of our Milky Way. Fact 92. Nebulas in the Magellanic Clouds. The large and small Magellanic Clouds, dwarf galaxies orbiting the Milky Way, host some of the most spectacular nebulae known to astronomers. The Large Magellanic Cloud contains the Tarantula Nebula, a colossal emission nebula producing massive star clusters and intense ultraviolet radiation. These clouds differ from those in larger galaxies because of their lower metallicity, meaning they have fewer heavy elements. This affects how stars form and evolve, often producing more massive stars that burn hotter and live shorter lives. Observing nebulae in the Magellanic Clouds offers a glimpse into star formation under conditions different from our own galaxy. Because these galaxies are relatively close, 160,000 to 200,000 light-years away, we can study their nebulae in remarkable detail, from the intricate filaments of ionized gas to the dense molecular clouds where protostars form. The Magellanic Clouds are natural laboratories for understanding the diversity of nebula processes across the universe. Fact 93. Nebulas in starburst galaxies. Starburst galaxies are cosmic firestorms, forming stars at exceptionally high rates, often triggered by galaxy collisions or interactions. Nebulae in these galaxies are extraordinary, giant clouds of gas and dust illuminated by clusters of newly formed massive stars. The intense radiation from these stars ionizes vast regions, creating spectacular emission nebulae that can span hundreds of light years. Stellar winds and supernovae sculpt the clouds into pillars, cavities, and filaments, and the chemical enrichment of the nebula is rapid due to the frequent death of massive stars. Studying nebulae in starburst galaxies helps astronomers understand how extreme environments influence star formation, feedback processes, and galaxy evolution. They are examples of how nebulae respond to extraordinary conditions, producing stars and shaping galaxies on an impressive scale. Fact 94. Nebulas in spiral galaxies. Spiral galaxies like the Milky Way and Andromeda are prime homes for nebulae. Their spiral arms concentrate gas and dust, creating fertile regions for star formation. Nebulae in these galaxies come in all types: emission nebulae energized by hot stars, reflection nebulae illuminated by starlight, and dark nebulae hiding new stars from view. The distribution of nebulae in spiral arms explains the patterns of star formation across the galaxy. Dense molecular clouds collapse into star clusters, while feedback from massive stars sculpts the remaining gas into spectacular shapes. By studying nebulae in spirals, astronomers can understand how galactic structure drives stellar birth and how chemical enrichment spreads throughout the galaxy. In short, spiral galaxies showcase nebulae in their most organized, visually stunning form, demonstrating the interplay between stars, gas, and galactic architecture. Fact 95. Nebulas in irregular galaxies. Irregular galaxies lack the orderly spiral structure of their more familiar cousins, yet they too are full of nebulae. These galaxies often have chaotic distributions of gas and dust, leading to scattered, sometimes massive star-forming regions. Nebulae in irregular galaxies can be especially bright due to concentrated star formation, and supernovae frequently enrich the surrounding gas. The Large Magellanic Cloud, for example, is an irregular galaxy whose nebulae showcase extreme star formation in a relatively compact area. Studying nebulae in irregular galaxies is crucial for understanding how stars form in less structured environments. It shows that even without spiral arms, gravity, turbulence, and feedback processes still drive the creation of stars, demonstrating the universality of nebular activity across different galactic types. Fact 96. Nebulae as cosmic distance markers. Nebulae aren't just beautiful clouds, they're also valuable tools for measuring cosmic distances. Certain types, like planetary nebulae, have fairly consistent intrinsic brightness. By comparing their known luminosity with how bright they appear from Earth, astronomers can estimate their distance. In nearby galaxies, bright emission nebulae also serve as indicators of star-forming regions. Their H-alpha light and other emission lines help establish how far the galaxy is from us, contributing to the cosmic distance ladder that astronomers use to map the universe. Using nebulae as distance markers has its challenges. Dust can obscure light, and variations in gas composition affect luminosity. Yet, these clouds remain reliable beacons, allowing us to measure distances across millions of light years. In a sense, nebulae are not just stellar nurseries, they are cosmic signposts, guiding astronomers through the vastness of space. Fact 97. Comparing nebula types. Across galaxies. Nebulae appear in nearly every type of galaxy, but their characteristics can vary depending on the environment. Emission nebulae in spiral galaxies often dominate star-forming regions along spiral arms, while irregular galaxies may have scattered, isolated nebulae. Planetary nebulae, formed by dying stars, can be found in elliptical galaxies where new star formation is limited. Dark nebulae, dense with dust, can be less common in low metallicity dwarf galaxies but still appear in pockets where gas accumulates. Comparing nebula types across galaxies helps astronomers understand how factors like galaxy structure, metallicity, and star formation history influence nebula properties. Despite differences, the fundamental processes, gas collapse, ionization, and feedback, remain universal, linking galaxies across the cosmos through these luminous clouds. Fact 98. Rare nebula phenomena outside the Milky Way. Beyond our galaxy, astronomers have discovered rare and exotic nebulae that challenge our understanding of star formation. Some galaxies host supergiant H2 regions, vast emission nebulae hundreds of light-years across, forming thousands of massive stars at once. Other rare phenomena include nebulae illuminated by extraordinarily luminous stars, producing unusual colours, or those shaped by extreme gravitational interactions in merging galaxies. There are even instances of ultra-compact planetary nebulae in nearby dwarf galaxies, providing insight into stellar evolution under unusual conditions. These extraordinary nebulae are not just scientific curiosities. They expand our knowledge of what's possible in cosmic star formation and the diversity of nebula structures in the universe. Fact 99. Nebula formation in galaxy collisions. When galaxies collide, nebula formation often accelerates dramatically. The interaction compresses interstellar gas, triggering bursts of star formation in regions that might have been quiet otherwise. These collisions can produce enormous emission nebulae and starburst regions rich in massive young stars. The Antennae galaxies are a famous example. Their collision has sparked the formation of numerous bright nebulae, many forming massive star clusters. Stellar winds and supernovae from these newborn stars then sculpt the surrounding gas into intricate shapes. Galaxy collisions show how nebulae respond to extreme environments. They are flexible, dynamic, and capable of producing intense star formation, revealing the power of gravitational forces to shape cosmic clouds. Fact 100. The future of nebula observation in other galaxies. The study of nebulae beyond the Milky Way is entering an exciting era. Next-generation telescopes like the James Webb Space Telescope, the Extremely Large Telescope, and advanced radio arrays will allow astronomers to observe nebulae in unprecedented detail. Future observations will reveal the chemical composition, star formation rates, and internal dynamics of nebulae in distant galaxies. Scientists will study how nebulae evolve over cosmic time, how starburst regions form, and how galaxy environments shape nebular activity. By exploring nebulae across the universe, we gain a deeper understanding of the life cycles of stars, the formation of galaxies, and the interconnected nature of cosmic evolution. Nebulae are not just clouds. They are bridges connecting galaxies, past, present, and future. Nebulas are more than just beautiful clouds in space. They're cosmic storytellers, showing us how stars are born, live, and die. Each one holds secrets about the universe's past and future, waiting to be explored. The next time you look up at the night sky, remember that hidden among the stars are these breathtaking nurseries and remnants, shaping galaxies in silence. Which nebula amazed you the most? Comment below and share your favourite cosmic wonder. Don't forget to like, subscribe, and hit the bell so you won't miss our journey through the universe's most incredible clouds.